How are you? I am Mr. Krause. This is from MrKrauseMath.com. I am going to work you through the Algebra 2 Trigonometry, the New York State Regents exam in Algebra 2 and Trigonometry for June 2013. The answer keys are always online, but fortunately the answer keys really just don't give you the information that you need in order to solve and understand what it is you're doing. So I will take you through the solutions for this particular trigonometry final. It is absolutely in your best interest to attempt to do these problems before you watch this video. There is absolutely nothing to gain from just watching this video and copying down what I do like a monkey, right? I'm not a trained monkey. I am a mathematics instructor. I believe that if you're given the right tools, that you should be able to find solutions and answers to your questions, and for you to be able to look up these answers and solutions for your own. But if you're a juvenile student, an immature student that is unwilling to do the work, it will not help you on the Regents exam come June this year or next year or whenever you're planning on taking the test. So please do yourself a favor. Do the problems on your own. Attempt them on your own. Get frustrated on them on your own. That is how learning takes place. It only takes place through failed attempts, and then you figure out things. Okay? So if you want to just check your answers, check your answers. If you'd like to just go through this video and enjoy my ranting and raving and bantering and whatever the next word is, go ahead. But I will take you through all the solutions of all the problems, and in some cases I'll take you through multiple solutions of the same question. To do this, I will be using the TI Inspire software as well. If you don't use this calculator in your classroom, it's relatively similar to the graphing calculators, TI-84 and things like that, but this one has buttons in different places. So I'll be using this one because this is what I use in my classroom, and I do not have the emulator for the TI-84 on my computer. If you would like the information on how to get this calculator, just visit MrKrauseMath.com. There's a link there. And if things should happen or change, probably look in the show notes at some point. There'll also be a link. Just go to education.ti.com or ti.net. But anyway, there's a link there. You'll be looking for the TI Inspire software. It's about $27 for the year, or if you want, you can just buy it outright for $112. All right, let's get started. I won't use the calculator too often because I don't necessarily agree with using the calculator. Oh, this one's going to be a little bit different. Okay, I got to go page by page. Page 2, which means every time I go to a new page, I gotta set it up. Kind of a pain in the ass. Okay, next. So we are looking for, in this case, data collection that will be, you're checking the viewer preferences for local news programming in Buffalo, and you want to collect the data that's appropriate. Well, very quickly, let's go through these. A census means you're going to ask everyone. If you take a census, that means you ask everyone. Probably not what you're looking for. If you take a survey, that means you're going to send out 100, 200, 1,000, I don't know, it depends on what the viewership is for that area. You're going to send out a certain number of questionnaires or things and asking people about what their needs are for viewing preferences. Looks like that might be the right answer. Let's keep going. You're going to observe. No, it's not. It doesn't even say newspaper or television, but I'm relatively certain there's no way you will be able to observe what the population is doing and what's going on in their head about their news preferences. And a controlled experiment, well, if you could think of a controlled experiment to figure out what people want for their news, for their news preferences, you're a much better person than I am. This is just one to know that you are, really it should have come down to one of these two, but nobody uses a census. That's why the United States government only does them every 10 years, because you have to ask everybody. So we will do a survey to just get a sampling of what people are thinking, to use that as our data to drive our decisions. And that's how almost everything's done in the society, through decisions. What is the number of degrees in the ankles whose radian measure is 8 pi over 5? The easiest way to handle these ones is to remember that pi is the same as 180 degrees. So what you're going to do is you're going to replace this. Now I know most of the teachers will say multiply by 180 over pi. Really what in effect you are doing is you're just going to replace pi with its degree equivalent, which in this case is 180 degrees. So we'll replace that with 180 degrees. I will take out my calculator, which I believe I have on the last screen. Good. And I will attempt to do this. And I will do 8 times 180, enter, divided by 5. Anytime you're doing fractions, it's usually in your best interest to do that. Now, this silly calculator will, oh, it gives us 288. Okay, perfect. So the answer is 288. Again, I think most teachers would probably, and when you talk about it at the beginning, you're just going to say, okay, you're going to multiply by 180 over pi. Notice the pi's cancel each other out. So really what you're doing is replacing the pi with 180. All right, moving on. 1-to-1, we're looking for. The two things that are key in this is 1-to-1 and onto. Now, in this particular problem, there are a number of these that are 1-to-1. 1-to-1 means for every input, there's exactly one output. So this is 1-to-1. This is 1-to-1. Nope, this is not 1-to-1. This is not 1-to-1 because this goes in two different places. So no, this one can't be anything. This one is 1-to-1. And this one is 1-to-1. For every one, 1-to-1 means for every one this way, there's one backwards as well. So I probably misspoke that the first time. So basically what I'm saying is A goes here and 3 goes back here. So that's 1-to-1. The 3 does not go any other place. You can always do plot these things. Now I'm not sure how you plot A. I guess you do A1. Need this A1, B2, and C is also 1. This function is it's a function, but it's not 1-to-1. Where is my pointer? This is not a 1-to-1 function, so I misspoke. It passes the vertical line test, but since it does not pass the horizontal line test, it is not 1-to-1. And when I should have realized it. I checked A quickly, and I didn't check B. B goes to 1, and C also goes to 1. So that makes it a function. In order for it to be 1-to-1, then you can only have one arrow going here. Notice I can't make a decision whether 1's going to come back to C or 1 is going to come back to B. So this is not 1-to-1. These two down here are in fact 1-to-1 functions. Onto just means that in what you need to remember as far as the Regents exam goes is every member of the range will be used. And in this case, notice this 2 is not being used. But over here, every member of the range was being used. And so for onto, you want to make sure that every value that's in your range was used in some place. So for 1-to-1, these arrows point to one and only place, and these arrows backwards, if you were to draw these backwards, only point to one place. That's 1-to-1. And onto means you want to make sure that all the range values are being used. going to be kind of a pain to have to, oops, get these to blow up every time. Okay. So you're looking at the 8 terms now here. Now, it doesn't tell you here whether or not it's a geometric multiplication or arithmetic adding sequence. You're going to have to kind of figure that out. So if you look at these, they go 3, negative 12. I can either subtract 15 or I can multiply by negative 4. If I go to positive 48 next, then we are not subtracting 15. We are multiplying by negative 4. So this is a geometric sequence. Now I could, if I wanted to, list these all out. Now this would be a pain. I think it's 3, negative 12, plus 48, minus 192. I think it's plus 768. Don't hold me on these. I think these are what I have written down. Minus 3072, plus 12,288, minus 49,152. And you could add all those up. But what if it said 100 or 50th? You'd be there for the entire test trying to do that. You don't want to do that. So we know it's a geometric sequence. We know it's because it's multiplying. So we're going to use this summation thing that you've learned. Let's see if I can draw this. That's not bad. And we're going to start n at, I think I started my n value at 0 and I went to 7. That would be 8 numbers. I'm sure there's a way to do it another way. So I do negative 4 n times 3. Actually, I think the way they do this, let me see if this works in class. This would work, by the way. This would give you this geometric sequence. If I type this in my calculator, I would get, let me put it over here. Let's see, I think I can get to it like this. And down here, I could just put x or n. I just choose n in this case. N, 0, 7. I'm going to have to use parentheses here. Negative 4, because if you don't do 2 negatives in parentheses, especially when you're dealing with exponents, you will not get it right. To the n power. And then times 3. Negative 39,321. There it is right there. Choice 3. And that is, in fact, the right answer. But I think the way they do this, let me get rid of this. Let me get rid of this. I think most teachers will teach it this way. You'll start at 1 and you go from 1 to 8. And in here you do n minus 1. So let's see if that works. I'm pretty sure that's the way we do this one. Let's just get the up arrow. And we'll retype this line and we'll change this to a 1. It really doesn't matter. We'll change this to a 8. And we'll change this exponent to n minus 1. We should get the same exact value. There it is. Negative 39,321. Same exact thing. Most teachers will use this. I think when I was going through it, I chose n, but most teachers will do this one. Okay. Okay, so this might be a preference of how your teacher goes about choosing this. I choose to make everything a fraction, and I choose to get rid of this thing by, you're basically multiplying by 1. But you're going to do so by multiplying the numerator and denominator both by the lowest common denominator. In this case, the lowest common denominator is, first of all, you all should be yelling at me for putting x's underneath there. The lowest common denominator in this particular case is x squared. So I'll put 1 underneath each one of these. And I'm going to put an x squared next to each of these. Okay. Then I'm going to go through and simplify. Well, nothing simplifies on this. I end up with just x squared minus one of these x's cancels with one of these x, and it leaves me 4x on the numerator. So no more fractions on the numerator. Got rid of that problem. Down here I will get x squared. One of these x's cancels with one of these x's. I get minus 2x. And then this x squared cancels with this x squared and gives me minus 8. So now I have to use one of my favorite tools, which is just to factor. So I'll take out an x, and I'm left with x minus 4. In the denominator, I'm going to factor this. They have to multiply to negative 8 and add up to negative 2. Well, that's very simply x minus 4 and x plus 2. Now I'll go back to start and divide out common factors. This minus 4 cancels with this. And it leaves me x over x plus 2. Choice 2. Yay! Alright, now we're doing some sine curves. Okay. So, since this does not start here and go out, which would be the sine curve, we know that since it starts at the bottom or the top, that it's going to be a cosine curve. So it can't be these. Unless, of course, it has a horizontal phase shift, and then it could be a sine curve. But in this case, none of the solutions in the answers had horizontal phase shifts. The amplitude is 2. So the amplitude in this case is 2. Well, that doesn't really help us out. Both of these have 2's in front. And it starts down here at the bottom, which means that they both start out at negative 2. So the fact that it started down here and not at the origin told us it was probably going to be a cosine curve. But that's about all you get from that. So now I got to go through and figure out the period. How long does it take to finish one complete cycle of this curve? Well, to finish one complete cycle all the way up and all the way back down and back to my starting point takes pi. Or another way to say this, it will complete 2 cycles in 2 pi. Well, this number right here, the B number, tells us how many complete cycles it will complete in 2 pi. So choice 3 is the right answer. Now, another way you could do this is to figure out the period and give me an opportunity to talk to you about period. The formula for period, and remember, the definition for you guys, or what you need to remember is the period is the time it takes to complete one complete cycle of the cosine curve. So that formula is 2 pi over b. So 2 pi over, and in this case the b value is 2. Those cancel, and I'm left with just pi. So it should take pi to finish one curve, and we did talk about that. All the way up and all the way back down over here to finish one curve. All right, down with that page. Just a few left, kids. Why does it do that to me? All right, blowing up. Okay, so you remembered at some point when you've got the inequalities, or the absolute value inequalities, that you're going to have to solve 2 equations. You're going to have to solve the original, 2x minus 1 greater than 5, and do not change the left side of the equation. Do not change the absolute value part of the equation. That stays the same. Everything else changes. We want it greater than positive 5 or less than negative 5. Those are the 2 things you need to solve. We're going to add the 1 over. I get 2x is greater than 6, or x is greater than 3. That leaves us not these 2. Now I'm going to solve this part of it. I'm going to add 1. I'm going to show you this work because I want to make sure you don't make this mistake. So I get 2x is less than negative 4. Divide by 2, and I get x is less than negative 2. Choice 1. All right, moving on. Range. Well, I'll tell you both. I'm going to tell you both. First of all, range is the y values. We're only looking for the y values. So I don't even care what those are. We're only looking for the y values. And in this particular case, the highest y value is 0, and it goes forever and ever and ever down to negative infinity. Or in other words, the y values have to be less than, or they could be equal to, 0. Just for fun, this could have been written in interval notation, and interval notation is kind of tricky here. It's from negative infinity all the way up to 0, but including 0. And that could have been written in interval notation. Man, done with that page. All right, so sine of 90 degrees, or theta plus 90. So anytime you are given one of these equations where it's sine and it's got a plus or a minus in it, that is going to say to you, go to your formula sheet and remind yourself, and I think it's on page 23. There it is. It's not always on page 23, but in this case it was. So I want the sign that has a plus sign in it. And that would be this equation right here. So it's sine A cosine B, cosine A sine B. So let me go back. I don't remember what page I was on. Nope, I guess I'm on page 5. It shrunk again. Okay, so this would be, let me get my red pen out. Sine of the first thing, which is theta. Remember, this is A and this is B. Cosine of 90 plus cosine of A, which is theta, sine of B, which is 90. Okay. You really need to have your trigonometric values, degrees, sine of 45, sine of 30, sine of 60, sine of 90, sine of 0, all of those you need to have memorized. It is not great not to memorize these. You can always use your calculator to figure it out. But you should know that the cosine of 90 is 0. And 0 times whatever this is just going to go away. The sine of 90 is 1. And 1 times anything is anything. So 1 times cosine is just cosine. And choice 4 is your answer. Make sure I'm not giving you any wrong answers. Okay, good. Moving on. That's it. That's all you have to do. Inversely proportional means that in your class you probably learned x times y is equal to some k value. In the first one, 2 times 3 equals 6. Oh, let me go back. This is still true. I just misread the question. It's inversely proportional to the square of x. Not square root, but the square of x. So we're going to square x times y and get k. So in this case, I get 2 squared times 3. And that's really 4 times 3 or 12. In this case, I'm going to get 4 squared times 3/4. 4 squared is 16. 16 times 3/4. You could use the calculator. I choose not to. Is also equal to 12. So now I'm going to do 6 squared times d. And if they're inversely proportional, they should also equal 12. Well, this is really 36d. So what I have to solve is 36d equals 12. Divide by 36. Divide by 36. And I find out that, 36, that d is equal to 12 over 36, which is not one of the answers, but this reduces to 1/3. So 1/3 is one of the answers. I'm going to pause this. I'll be right back in a second. Well, I'm back. I don't know how long of a pause that was for you. I had to take a couple second pause. Um, I, I forgotten. I'll show you in a second. We got to get this to the nearest minutes, okay? And I use the TI Inspire. I think the TI 84 actually is a little bit easier for this one. I'm looking for angle S. So this is my theta here. And you need to remember your trigonometric ratios. Some old horse caught another horse tripping on alligators, or whatever you learn. If I label this diagram, if I'm looking for this is the opposite side and this is the hypotenuse. So it should be clear that I want to use sine. So you need to do sine of theta is equal to 8 over 17. But I don't want that. I want to somehow get the sine onto this side. Now, you know, you will have gone through the theoretical lecture of how to do that in class. I'm not going through that. You should know by now that you need to use the inverse sine function, which is the sine -1 of 8 divided by 17. But if I do that on my calculator, first of all, I want to make sure that I get the right answers. You'll notice if you just hover over this, that it will tell you what degree mode you're in. So if you just clear that and you hover right over that, you'll see that I'm in radian modes. And that's really not going to help me when I'm looking for degrees. So the first thing I want to do is go into the home. I want to go down over here into settings, and I want to go into document settings, and I want to change from radians to degrees. Otherwise, it will not work. And choose OK. Now I'll go back into my calculator. Now, I'm not sure what I'm in right now. Just hit enter. I need to do the sine, so I want to do the inverse sine, which is you hit this trig button, and you go to sine of 8 divided by 17. Well, that actually is not going to be very useful, because that will just give you the decimal value. And that looks like it's not in the right mode. That should give me 28 or 61, and it did not. So notice I'm still in radian modes. All right, go back into here. Sometimes you have to do this. I'm not sure why they make you do this garbage. We'll click into degree mode, and we'll choose make default. That makes it the default for anytime you're going to do any calculations. Now I go into calculator, and it should tell me I'm in degree mode. If I hit the up arrow, I mean, clearly 0.489 degrees. It doesn't make any sense, right? It should be either 28 or 61. In this case, it's 28. So at this point, I already know that it's not one of these two. But I still need in degree minutes seconds. And the clearest way that I've been able to find this, and the only way I've been able to find this, what I was just looking for to see if there's a better way to do this. I'm going to keep looking. I hope there is. But I go into catalog. Now you can hit the scroll down button, but you're going to be there for quite a while because there's a lot going on. Or you can just start typing. If I type in D, it takes me to the D's. If I type in M, oops, go back to the D's. I thought you could just type in DMS, but whatever. I typed in the D's. At least it gives me down here. You'll find here it is. This arrow means take whatever previous calculation was done and DMS it. Degree, minutes, seconds. And we'll just double click on that and hit enter. So that says take the answer and DMS it. And we hit enter. So I get 28 degrees, 4 minutes, 20.953 seconds. But we need the 28 degrees, 4 minutes. That will give us choice 2. All right, that's it for that one. Okay. Which order pair is in the solution set of this? So this first one, let me just do this. It's y squared minus x squared. And we really want that to be negative 32, because if I bring this 32 over, I need that to be negative 32. Well, if that's going to be negative 32, then wouldn't it make sense that x would be bigger than y? Now, bigger is a relative term, With negative or positive, it doesn't matter which one, it's going to be bigger. So x is not bigger than y here. This would be, y is much bigger. This would be 36 minus 4, which would be positive 32. That would not give us 0. This one's bigger. 3 squared is 9. 9 minus, or wait, 1 squared is 1 minus 9. It's not going to give us 32. So it's clearly not one of those. It's probably not this one either because it's such a small number. So if I'm going to check, I'm going to check this one first. If I put in x squared as being negative 6 squared, that's positive 36. Excuse me. I'm going to put in negative 6 in here for x. That gives me positive 36. I'll put the negative 2 in here for y. That gives me positive 4. 4 minus 36 is in fact negative 32. But I want to really make sure that I'm right. So I'm going to check it in this one. 3 times negative 2 minus negative 6. Does that in fact equal 0? Well, this is negative 6, and 2 negatives make a positive, and positive 6 equals 0. So there's my answer. All right, page 6 finished. Only a few left to go. All right, there's a couple of different ways to handle this problem. I'll do it straight from the formula. A equals P e to the RT. So, common mistake. Probably the most common mistake is not using the right percentage. So let me get all the information down I have. We want to, where is it, double our money. So I've got everything I need. The rate is 5%, but as a decimal, and this is where the common mistakes are made, that's 0.05. I don't know the years. My principal amount is 500. What we're looking for is the time it's going to take. So it's a double. So really what I want to do is I want to make $1,000. I want to make $1,000. So my final result is going to be $1,000 equals 500 e to the rate, which is 0.05 times t, which is time. Now, quite simply, if I wanted to, I could just use the answers to solve this. Really what I'm looking for is if I divide by 500, I want e to the 0.05 t to be equal to 2. I'm going to use logarithms. If I take the natural log of both sides, so I get the natural log of 2, because the natural log and e are inverse functions, I get the natural log of e to the 0.05 t. If you remember when you do logs, these come out front. So I get natural log of 2 equals 0.05 times t, the natural log of e. Well, let's go back and take a look real quick. What is the natural log of e? You all should know that. If I do the natural log of e, it's really e to the 1. I should just get 1. So really this just goes away. So to solve, I'll divide by 0.05. And if I go back to my calculator and I take the natural log of 2 and I divide by 0.05, I get 13.86 something. Looking at my answers, 13.9 looks pretty good. I want to check it. I want to make sure I'm right. Very simple to check. We'll just type it in. 500 was my initial investment. E to the 0.05 times, and the answer we picked was 13.9. So it should be close to 1,000. There it is. Very close to 1,000. And there's my answer. This next question is a rather tricky question. Very tricky question, if you ask me. I'll bet there was a lot of kids that missed this on the Regents exam. You'll have to remember that negative exponents have absolutely nothing to do with being negative. So what I'm going to do is I'm going to convert all these first to what they really are. The first one is 6 over n squared is less than 4 over n. The second one is n over 4 is greater than negative 6 over n. The third one is 6 over n is less than 4 over n. That looks like a pretty easy one to check right there. 4, if I don't know that, is 4 over n is greater now. Now this one's going to change a little bit since the 6n is in parentheses. It's 1 over 6n. Now the trick to this one is which is always true. So you should try positive and negative numbers. Let's say I put n equal to 2. Well, originally this would be 6 over 4 is less than 4 over 2. That's true. That's true. But what if I made it negative 2? Well, this would be 6 over 4 still is less than 4 over negative 2. And that is not true. So this does not work. So let's try 2 over 4. That's 2 over 4. That's a half. Is that greater than negative 6 over 2? And absolutely it is. It absolutely is. That's 1/2 is bigger than negative 3. But if I change this to a negative, this is negative 1/2. Is that greater than positive 3? Nope, it is not. Again, 6 over 2 is 3. 4 over 2 is 2. Is 3 less than 2? Nope. Oh, that's the right answer, 3. I'm not sure why I got the wrong answer. Let me think for a second. What am I doing wrong? Oh, man. I misread the question. It said right here, if n is negative. That's a common mistake made. I knew this was a tricky question, and I forgot that it had this negative part in here. So clearly I should not even have been checking any positive. I should be checking negatives, because when this was positive, this is actually not a true statement. But when n is negative 2, this would be negative, and this would be also negative. But negative 3 is smaller than negative 2. And that's your answer. And I can check it again in here too. Put in negative 2. This is 4 over negative 2, which is negative 2. Is that greater than 1 over negative 12? Well, remember, when you're working with negatives, everything's backwards. Negative 2 is much smaller than negative 1/12. All right, moving on. And let me get rid of some of this stuff. So I have room to work. All right, so the thing is, we really need to figure out what this is. I think I'm going to show you 2 different ways here. K is the thing that's changing. So I'm going to check this. I think I can check this on my calculator. I didn't even try this beforehand, but I'm going to check this on my calculator. So we'll do the 4 plus, but we got to figure out what this stuff is. So if I plug in 2 for K, I get 3 times 2 minus X. And then I'm going to add 3 times 3 minus X, right? Isn't that what this is? Plus 3 times 4 minus X. Plus 3 times 5 minus X. And this is 6 minus 3x, 9 minus 3x. Oh, that 3x was repeating itself, huh? 12 minus 3x and 15 minus 3x. So it's minus 12x, so it can't be one of these two. There's 4 minus 3x's. Now I just got to add these up. 15, 27, 36, 42, 46 looks like the right answer. 46 minus 12x. There it is. For some reason I had in my head that it was choice 3. I'm wondering if I could use my calculator to check this. So I'll go here and I'll go back into this summation and we're going to use K, and they're going from 2 to 5, and it is 3 parenthesis K minus. Now I'm just going to pick any value for X here because otherwise it will give you some random thing, and I'm going to pick 10 for X. It just makes it easier. Whatever value you pick for X, we're going to pick 10, and we get negative 78. So if that's true, I should be able to go down here and go, okay, 46 minus 12 times 10 should also be negative 78. Oh, but I forgot. Oh, up here I forgot the plus 4. Up here I forgot the plus 4. That's a big, huge mistake. That's why we're off by 4. I should have put a 4 plus on this because that was the entire thing. And there you go, negative 74. Forgot that. That would have been kind of scary. So, all right. Strong correlation. If you remember correctly, strong linear correlation has... I'm not sure why it's doing that. Go back to this. Okay, maybe I can draw now. If you remember, strong linear means we're going to be close to 1. I don't know why it's erasing. So you're gonna have to listen to me because on this page it's not going to work. So we're going to want it to be close to 1 without going over. So in this particular case, we can't choose choice 3, even though that's the closest value to 1 because it went over 1. It can't be over 1. So we have to choose choice 1. It's the closest one that's positive. That's got a correlation that's close to positive, and it's close to positive 1. Excuse me. All right, let's see if I can draw on this one. Now go to stain. Okay, which problem involves evaluating 6p4? So what this is, it's 6 things, and you want to pick 4 of them where order makes a big difference. You're not doing combinations. Combinations are things like committees or teams or groups. Permutations are when order matters. First place, second place, third place. So how many 4-digit ID numbers can be formed using 1, 2, 3, 4, 5, 6 without repeating it? So the numbers 1, 3, 6, and 4 is different than 1, 3, 4, and 6. It's the same numbers, but it's a different permutation. So that one looks like it's right. Choosing subcommittees. Subcommittee is the key word for combinations. How many different outfits can be made using 6 shirts and 4 pairs of pants? Well, you're not going to take 6 shirts and pick 4 pants. That doesn't even make any sense. And how many different ways can 1 boy and 1 girl be selected from a group of 4 boys and 6 girls? Well, does that mean we're going to have 6 girls, and from those 6 girls, we're going to choose 4 boys? Doesn't make any sense. So choice 1 is the only right answer. All right, so what you need on this one is you need the center. So that's the first thing you're going to need, and that center is -3, 1. So it can only be, remember, when you put the center in, it goes in backwards. It can't be 1, and it can't be 3. Those don't make any sense. The next thing I need to do is, if you remember correctly, the formula for this is the x's squared plus the y stuff squared equals the radius squared. And we already now know that it's x plus 3 squared with the x stuff. The y stuff is going to be y minus 1 squared. But we need to know what the radius squared is. And you can't guess. You must show this by picking a point that is actually on the radius. I need to know that distance, and I do this by using the Pythagorean theorem. Very quickly, this is 3, and this is 2. So, 3 squared plus 2 squared equals the radius squared. Well, isn't the radius squared what I'm looking for? Sure is. 3 plus 4 is 13, or excuse me, 9 plus 4 is 13 is equal to the radius squared. That goes in the formula. Choice 4 is the right answer. And we're done with page 7. Moving on, kids. No problem, we got 19. All right. So we're going to replace x with 3i. We're going to replace y with 2i. And we're going to squared. And we're going to replace z with m plus I. All right, so not a lot to do here. This is 3i. This is 4i squared times m plus I. We're getting close. 4i squared is really negative 4 because I squared is negative 1. So this becomes negative 12i times m plus I. Well, that gives me 12mi plus 12i squared. Well, how many 12mi's do I have? 2. Now, this is really negative 1, so this really is negative 12. So what I have here is negative 12 plus 12mi. Oh, let me go back. I made a mistake. I apologize. It's early. I'm a little brain dead. I just said it was negative 12. I wrote down 12 for some reason. Some of you are probably like wondering what the heck I'm doing. It's really, this work right here is negative 12i. So when I distribute that, I get negative 12im minus 12i squared. Now, we just set it up. I'll say it again. I squared is really negative 1. So this thing becomes positive 12. So my final answer is 12 minus 12im. And that's choice 3. Okay, so let's think about this. Angle terminates in quadrant 2. So everything's positive here. Let's think about what's negative here. Sine is positive. Cosine is negative. Well, if sine's positive, then cosecant is also positive, and secant is negative. So now I want to figure out what they have here. Oh, the other thing is, since sine and cosine are both positive negative, I know that tangent is also negative in this quadrant, which makes cotangent also negative. Okay. So we're in quadrant 2. If cosine is negative, that works. Cosecant is negative. That's what this says. Nope. Sine is positive. Check. Cosine is positive. Nope. Can't be that one. Cosecant is positive. Check. Cotangent is negative. Check. That looks like it. That looks like our right answer. Check it with the last one. Make sure I didn't make a mistake. Tangent is negative. Check. Secant is positive. Nope. There we go. Done. Okay. Common mistakes on this one. Log. This is really 4 times m squared. The squared is only with the m. If you remember correctly, multiplication comes from addition when you're working with logarithms. So this is really log 4 plus log m squared. But if you'll also remember, squareds or exponents come in front of the logarithms. So this should be log 4 plus 2 log m, choice 3. Moving on. Now, when I first saw this question, I'm like, there's no triangle. What's going on here? Why don't they have a triangle drawn? Because you need to draw it. You need to create your own triangle. P, Q, R. And P is right here. Little p is right here. Little q is right there. And little r is right there. Remember, capital R's for the point, capital variables for the points, and little r's for the vertices. I want to know what P is equal to. Let me go through my law of sines here real quick. A law of sines would say sine of R over R is equal to the sine of P over P, which is equal to the sine of Q over Q. We're going to end up cross-multiplying, and we want to see if we can come up with one of these answers. So this first one has R, P's, and Q's. Not really going to work. What we want to do is, you can't have all 3 letters in there. You can have 2, but you can't have all 3, because we're going to use any 2 of these to do some cross-multiplying. So I'm going to eliminate that one right away. You'll see when we get to the right answer. This one has 2. This one has 2, and this one has all 3. So I'm going to guess 4 is not it. So it's going to be one of these 2. So let me cross multiply. Oh, by the way, this should be in sine of R. Let me cross multiply with this one, just this one right here. So I get P times sine R equals R times sine P. If I divide by, if you want to know what P is equal, I divide by sine R. So I get P is equal to R times sine P over sine R. Oh, there it is right there. Done. I think you should be able to know a lot about angles. I'm pretty certain you can type this one in your calculator and get it. Let me go. I'll do that at the end. So what this says is the tangent of some angle is going to be equal to the square root of 3 over 3. And my kids are going to have to memorize that the tangent of 30 degrees is the square root of 3 over 3. So what I really want to know is arc cosine of the square root of 3 over what is really going to give me 30 degrees. So what it's saying is, really what this is, when you have an arc tangent, we're really trying to figure out what's the angle measure that's going to give me the square root of 3 over 2. Oh. I lied like a dog on that one. I already know what the answer is. What I want this to be 30 degrees. So the cosine or the arc cosine of what will give me 30 degrees over 2. Now, you should be memorized. You're probably, you're working with cosine or whatever, you're going to be doing either the square root of 3 over 2 or 1/2. I guess I would have tried 2 first on this one. But the angle whose cosine is 3 over 2, well, that angle is 30 degrees. That will give us that. So square root of 3 over 2 is our answer. It goes in. So we want this to turn out to be 30 degrees. And the only way for that to be 30 degrees if you're taking the arc cosine of square root of 3 over 2. So the answer is choice 2. And I believe you could check this. Arc cosine is the same as the inverse cosine, so we'll do the tangent of the inverse cosine of the square root of 3 over 2. And then you have to figure out what the square root of 3 divided by 3 is, and it should be 0.577. There you go. Ow! Leg hurts. Same answer. That's a trick question, the tricky question. All right, moving on. We're almost done. I think what I'm going to do on this question is just rewrite these first. So I'm going to move my negative exponents. Negative exponents have nothing to do with being negative. They only have to do with being reciprocals, or, movement. We're going to move these. These x to the negative 2 really belong down here. Remember, x to the negative 2, which is really x over 1, really you're just going to take the reciprocal of this and change that to a positive exponent. Y to the negative 5, that's got to come up here. Y to the negative 2, but it becomes positive. Y to the negative 2 comes down here, and it becomes positive. Now I can simplify it. 2 goes into itself once, 2 goes into 4 twice. Nothing to cancel with the x's. These two y's cancel with 2 of these y's, leaves me 3. So I have y cubed over 2x squared. Choice 1. Moving on. So we have to rationalize the denominator. So they gave you kind of a tricky one. You're going to multiply by the conjugate, which is the same exact fraction as the denominator, but with a plus sign. Now, I teach my kids when you multiply by the the conjugate, you don't really have to do all of the double distributing. And I'm going to just do this for now, just in case I can simplify for later. So I'm going to multiply these two together, and I get x squared. I'm going to multiply these two together, and I get minus x. I don't have to do all the double distributing because the two middle terms are going to fall out. They'll just cancel. Don't do something stupid. That's got to be in parentheses, but I can factor out an x, and I'm left with x minus 1. Now this x will cancel with this x. So I'm left with x plus the square root of x over x minus 1. Choice 4. Moving on. All right. We got a common ratio here. So I got to figure out, first of all, how do I go from 1/64th doing something to it that I get negative 3 over 32. And then doing that same thing, I'm going to get 9 over 16. Well, let's see. If I multiply this by negative 3, I can't multiply by negative 3 because that would give me negative 3 over 64. That's not going to work. I need to divide that by 2. So here's what you got to do. You got to figure out 1/64th times some value is going to equal negative 3 over 32. Well, in order to do this, we're just going to multiply by the reciprocal. 64 over 1, 64 over 1. Goodbye. I get x equals, this goes in here twice, negative 6. So negative 6 is going to be part of my answer. So I know it's not choice 1 or choice 3. All right, so I took care of that part. Now what did I do? I got rid of 2 A's but added a B. So I'm going to in order to get rid of anything, that's got to go in the denominator. I'm getting rid of 2A's, so I'm going to divide by A squared, but I'm getting a B, so I have to multiply by B. And so that's why choice 2 is your answer. And then they decided to end with a very difficult question, I think. K, L, M. K, little l, little m. LM is 13. Angle K is 40. KL is 20. And I want to know the measure of angle M. Well, I can simply do the law of sines. Sine of 40 over 13 is equal to the sine of M over 20. And if I cross multiply, I get 20 times sine 40 equals 13 times sine M, and then I just divide by 13. So if I do that in my calculator, the sine of 40 times, I think it was 20, divided by 13 is 0.9888. So I get sine of M is equal to 0.9888. So you need to do the inverse sign to get M. So you get M equals, and we'll do the inverse sign here. Tangent sine of the answer, control negative, and you get 81.45 degrees. So 81.45 degrees. Now, if you are just an untrained, very immature student, you will immediately pick choice 1. It is not the answer. And I will tell you why. This is one of those how many triangles can you make questions, but asked in a different way. So I've got 40 and I've got 81.45. That's 121. So it leaves us about 59 degrees for the last angle. But if you remember correctly, 81.45 degrees is right about here. That's the reference angle. But I could also do a reference angle of 81.45 degrees here, because that also is equal to this 0.988. So really what I have to do is I have to take 180 and subtract off this 81.45. Well, that's going to give me like 99 or 98 degrees. Let's say it gives me 98. So if I take the 40 and I add in the 98 degrees, that's about 138, which leaves me plenty for a third angle. So I can make 2 separate triangles from this one. Measure of angle M. So I can make 2 separate triangles from this one. So it's the ambiguous case. It's ambiguous, choice 4. It's interesting, though. I think the answer still could be between 0 and 90 both times. But it is ambiguous. Oh, this said it must be between, but it is the ambiguous case, so I'm pretty sure the answer is choice 4. I believe that's what I looked up. Okay, just to make sure, let me look it up because I have all the answers somewhere. This is June 2013. Choice 4, ambiguous. There she is. All right, here we go. Moving on, page 10. Let's start these problem 2s. All right, let's get to some more. This is the more fun stuff. Okay, it's not. All right, you have to memorize. This one's very simple. The sum of the roots is negative b over a, which in this case, that's an a, is negative 1 over a, which is 12. So there's your sum of the roots. Sum equals negative 1 over 12. The product of the roots is c over a. In this case, the c is negative 6 over a, which is 12. So the product is equal to negative 1/2. There's your 2 answers. Moving on. Nothing else on this page. Going to page 11. Okay. So in order to solve this, you can raise this side 27 to this, and this side do 27 to this. This 27 and log 27 cancel each other out. You get 2x minus 1 equals 27 to the 4/3 power. Now you can either put that in your calculator, or you can use your brain for more than growing beautiful hair. Clearly that's what I'm doing. The denominator is a cube root. So the cube root of 27 is 3 times, or raised to the 4th power. So 3 raised to the 4th power is 81. So really just put in your calculator, I'll give you 81. Add the 1 over, I get 2x equals 82. Divide by 2, and I get x equals 41. There's your answer. Moving on. Already on page 12. All right, this is just one of those permutation questions. There are 10 different letters, so we're going to do 10 factorial divided by all the repeaters. So 1, 2, 3 s's, 3 factorial, times 1, 2, 3 t's, 3 factorial, times 1, 2 i's, 2 factorial. So I bust out the calculator. I'm going to do control division. 10. Oops. It's not there. It is. Is it here? Yeah, here it is. Factorial over 3 factorial times 3 factorial times 2 factorial. And we get 50,400. So 50,400. Done. Next problem. Express the product end of this in simplest radical form. Well, I think you should have this memorized. This product of the cosine of 30 is the square root of 3 over 2. The sine of 45 is the square root of 2 over 2. If I multiply those, I get the square root of 6 over 4. Done. All right, so I'll do this problem like this. 5 cosecant theta equals 8, or cosecant theta equals 8 over 5, or cosecant is really 1 over sine theta equals 8 over 5. Well, I can just take the reciprocal of both of these sides. So really what I get is sine theta over 1, which is just sine theta, is equal to 5/8, which means I'm going to do the inverse trig function, or the inverse sine of 5/8. So theta is equal to sine -1 of 5/8. Show all of your work. So I'll come over to my calculator. I'll do the inverse sine of 5 divided by 8. And I get 38.6822. 38.6822. There we go again. It's not going to let me freaking write on here again. I don't know why it does that. Anyway, this said you have to round to the nearest degree, so the answer is 38.68. That would be 39 degrees. But you got to come back in. It says solve algebraically the measure of the obtuse angle that will work. Remember, this is the angle in the first quadrant. Sine can also equal 5/8 in the second quadrant. So you have to take 180 and subtract off 39, and you get 141 degrees. So 141 degrees, and again, I cannot write on here for some doggone reason. Oh, now I can. Oh, and it's going to stay. So this gives me theta equals 39 degrees, but that's not obtuse. So what you have to take is take 180, you got to subtract off 39, and you get 141 degrees, and that would be your answer. Page 14. All right, this isn't bad. So we're going to do g of 10 is equal to 10a square root of 1 minus 10 squared. We'll take care of the squared later. This is 10a times the square root of negative 9 squared, which is equal to the square root of this. So this is really, let me get back to my red pen. This is really 3i. So what I have here is 30i squared. Oh, don't have squared yet. 30ia squared. 30 squared is 900. I squared is I squared. And a squared is a squared. But that's not good enough. It says in simplest form. I squared is negative 1. So really what I have here is negative 900 a squared. And that's the final answer for that question. These are some of my most favorite questions. You're just simply taking things and you're converting them. So cotangent of x times sine of x all over secant of x. So what we're going to do is we're going to convert these all to fractions. So this is really cosine of x over sine of x times sine of x over 1 all over 1 over cosine of x. Well, clearly these cancel. So I'm left with cosine of x over 1 divided by 1 over cosine of x. But when you divide, you're really flipping and multiplying. So we're really going to take this, flip it, and multiply by it. Cosine of x over 1. So I end up with cosine squared x. And we are done with that problem. So Abby, who is this stellar, amazing student, decided to randomly guess on 7 questions, each of which has 4 choices, each of which has equally high or equal same probability. And we want to figure out what's the probability that she gets exactly 3 questions correct. So we're going to do 7, choose. How many questions is she answering? We want to get exactly 3 correct. So this 3 represents the number that we want correct. Well, if there's 4 probable choices, that's a 1 in 4 chance of getting it right. The 3 goes here. This also means that you have a 3 in 4 chance of getting it wrong. And so if she's going to get 3 right, that means she's going to get 4 wrong. And that's what I want to put in my calculator. So I'm going to go into menu, probability, combinations, 7, comma, 3, parentheses, and I can do 1/4, but I'm going to do 0.25. Same thing. Raised to the third. Careful to get out of the exponent mode right here. Parentheses, 0.75. Raised to the fourth power. And this should give me 0.1730. I'm not going to use that. So this is equal to 0.173035. So it wants it rounded to the thousandths place, which is 3 decimals, 0.173. There it is, kids. Done. That problem's over with. We're moving on up. 17. Now we get 4-point questions. Okay. These aren't bad. Simplest radical form means you are not going to be able to factor this. You're going to either have to use the quadratic formula or completing the square. So, first things first. Common denominator is x. I'll multiply everything through by x. So, I get 13 equals 10x minus x squared. Never do you want to have your x squared to be negative or your highest x to be negative. So I'm going to move everything to this side. X squared minus 10x plus 13 equals 0. Now, because this has a 1 out front and an even b term, I could use completing the square. So I'm going to do that over here. I'm going to complete the square over here. So my first step is to bring the 13x, or the 13, over to the other side and rewrite this with 2 boxes. I'm going to take half the middle term and square it, but I'm going to put that half in a perfect, or a binomial squared, because we're creating a perfect square trinomial. So the half of 10, or negative 10, in this case is negative 5. Negative 5 squared is 25. So I'm almost done. This is equal to 12. In order to complete solving this, I have to take the square root of both sides. And you remember, when you take the square root, you have to put a plus or minus. So I get x minus 5 is equal to plus or minus the square root of 12, which I'm going to write as 4 times 3. Because what is the square root of 4? 2. And it's said in simplest radical form. So my answer becomes x is equal to, when I move the 5 over, 5 plus or minus 2 radical 3. So that's doing it by completing the square. I can also use the quadratic formula, which says x is equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. You remember the quadratic formula. So a equals 1, b equals negative 10, and c equals 13. And I make my kids find the discriminant, which is b squared, which is 100, minus 4 times 1 times 13. Let's see. 13 times 2 is 26, times 2 is 52, so this would be 48. 100 minus 52 is 48. So, I'm almost done now. X equals negative b is positive 10 over 2 times 1 plus or minus. Now the square root of 48, I'm going to already start to simplify, because the 48 goes in here. But I'm going to write it as 16 times 3, because that's almost simplified already. And then 2 times 1. Square root of 16 is 4. This 2 cancels with this 4 and makes this 2. 2 goes into 10 5 times, and I'm left with x equals 5 plus or minus 2 radical 3. And either way, you arrive at the same solution. Moving on. Page 18, problem 37. We're almost to the end here, kids. A ranch in Australian outback is shaped like a triangle ace. Well, mate, I don't even know. Wait, how do British people talk? I just lost my British accent. I can't even do British accent. And I say British because they speak like with a British accent in Australia. You know, mate, go down to Australia. Yeah, have some shrimp on the barbie. Uh-huh. So let's see. AC is 15. Angle A is 42. Angle E is 103. So we're going to use the formula area is equal to 1/2 AB sine C. In order to do so, what I really need to find is this side. And I'm going to use the law of sines to do that. So sine of 103 over 15 is equal to the sine of 35 over x. Whoa, 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 whoa. Where did 35 come from for Krause? I don't even know. 102 plus 40, 103 plus 42 is 145. 180 minus 145 is 35. So this angle up here must be 35. Okay. Cross multiply. I get x times sine 103 equals 15 times sine 35. Divide by sine 103. And I get x equals, I think you should take my word for it, 8.2996. A real hard time writing numbers. Okay, 996. 8.8.8.296. Okay, so now I have this side. So now I have all that I need in order to use my formula, which I'm going to do in green and small. So area equals 1/2 the product of the two sides that I have there, 8.299. Oh, I did it again. I forgot the 8. I don't know why I keep forgetting that 8. 8.82996 times the sine of the angle between them, in this case 42. And if I do that, I get, and I could put this in my calculator, I get 44.313. So my area is equal to 44 square miles. I think we got two left, 38 and 39. Okay, children. We're going to need to use our calculator for this one. So I'm going to be looking back at my sheet over here while oh no, I can do it right here. I think I can. Okay. Bring up my calculator. Okay, so in order to do this, perfect. We're going to go back to the home screen and we're going to go spreadsheet. And this is only one set of data, so I can just start typing these in. 29, enter, 28, enter, 39, enter. Don't make a dumb mistake. 37, enter, 45, enter, 41, enter, 40, enter, Okay, I screwed up something. 38, enter, 37, enter, and 48. All right, so I have 10, but I screwed something up. So let me make sure. 29, 28, 39, 37, 45, and then for some reason I went 41, but I did pick up that I missed the 40, 38, 37, and 48. And then we want to click on Menu, Statistics, and we're only doing stat calculations. We're doing one variable statistics. We want to figure out what the average is, the mean, and we want to figure out what the standard deviation is. And my list is in A, so that's fine. It's only got a frequency of 1, and that's fine as well. So I have found that my X bar is 38.2. So my X bar equals 38.2. And my standard deviation, which is R, not S, that's the sample standard deviation. We've got a population, which is 5.8 or 5.9. So if I want to go one standard deviation out from 38, I'm going to go down 5.9. And I want to go up 5.9. So I'll take my calculator and I'll figure out, I'm going to calculator, what is 38 minus 5, 38.2 minus 5.9, and I get 32.3. So the lower end is 32.3. And my upper end is going to be 44.1. So how many scores are within one population? So what I'm going to do is I'm going to highlight all the ones that are in between these things. That's really from 33 to 44. 33 to 44, 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 33 to 44. So that looks to me like there are 6 scores that are within one standard deviation. Now the next question says, what is the interquartile range? Interquartile range is quartile 3 minus quartile 1. So go back to your calculator. Go back to... let's do this. Go back in here. Got to go back to where you were working. And quartile 1 is 41 and 37. So 41 and 37, or 4. Last problem. We are on the last problem, and it's an easy one. Last problem. And it is not a difficult question. So here we go. You guys ready? First things first, we're going to move that 16 over. So you get x to the 4th. Hate that big fat pen. Plus 4x cubed plus 4x squared plus 16x. I'm going to factor by grouping. Oh, equals 0, because we're solving this, right? It says solve, right? Solve means I'm going to come up with answers. It doesn't say just factor. Well, this had to be one of the easiest last problems. I'm going to take out an x cubed. I'm left with x plus 4. Here, I'm going to take out a... Yeah, that's why. First things first, kids. You should take out the GCF. The GCF is x. And I'm going to be left with x cubed plus 4x squared plus 4x plus 16 equals 0. Now I'm going to finish by factoring and take out an x squared here, and I'm left with x plus 4 plus 4. So I'm grouping these two, take something out. Group these two, take something out. x plus 4 equals 0. Almost done. My answers are going to be x. My first set of parentheses are these ones, x plus 4. My second set is these two, x squared plus 4. It's these two put together to give you this parenthesis, equals 0. Not quite done. I've got a number of different answers. Let me do these in green or blue, because the last answer, blue. X equals 0 is an answer. X equals negative 4 is an answer. Those are your two real solutions. Now you're going to have actually a couple of imaginary solutions, because, let me show you this. You're going to do x squared minus 4, plus 4 equals 0. You're going to subtract 4 from both sides, so you get x squared equals negative 4. You take the square root, and you got to remember, when you take the square root, you got to remember to put a plus or minus. And x is equal to plus or minus 2i. And there's your last two solutions. And that is it for June 2013 Algebra 2 Trigonometry Regents Final. I hope you all enjoyed it. There will be plenty more. If you want one that you want, just let me know.